Hey everyone, thanks for coming to our session today on hacking through BIM models. BIM stands for Building Information Model. It's basically a database that represents all the digital data of a building. This data includes information about its architectural design, engineering calculations, and construction strategies. Our buildings are getting smarter and smarter, so once you have access to a BIM model, you can do some pretty cool hacks. In today's session, Yorik and I will show you how to use open source software, Ifc OpenShell, FreeCAD, and the BlenderBIM add-on to view and write scripts to hack on these BIM models. So let's get started.
Hi everyone, I'm going to show here how to quickly open an Ifc file and check the contents of the file. I'm taking here an example file on this site that has a couple of model files free for download and see. And I'm using this application that's Ifc++, and that's an open source application available on Linux and Windows, and I think Mac. It's a very simple application, but it lets you open an Ifc file and see the contents. Here we see that we have a couple of junk objects that we could remove. And we see also a problem is that all our walls, you see that all other walls here are not Ifc walls, but are saved as generic objects.
In our first BlenderBIM add-on hack, we're going to use Blender to view Ifc models. So back in Blender, browse to your file, and let's go. You'll see the model in 3D. You'll also see names like windows and doors and so on. You can see some basic attributes as well as the type of object it is over here. When you see an object on a 2D drawing or in a blueprint, you should be able to find the exact same name in the BIM model. If you scroll down, you'll also see other groups of properties. But typically you'll see things like fire ratings, materials, and whether things are load-bearing. Blender comes with a built-in Python console. It's like a JavaScript console, but with more white space. Both FreeCAD and the BlenderBIM add-on use the same underlying library, Ifc OpenShell, so once it's imported, we can do all the usual tricks like loading models. We can also count the doors in the model, and let's find out who is responsible for this design. You can get the results with key value pairs just like this. Also, at any time, you can just use the autocomplete tab function and you can see all the data that an object has. Now the whole point of using a Python console within Blender is to interact with our active model. So let's grab data from our active file. We can also grab elements from our visual selection. So let's select an object in the viewport like this and let's load it. And let's view its attributes. We can also view all of its properties. And all of these attributes and properties are exactly the same that you're seeing in this interface here. Now, just like how browsers have a DOM inspector, select anything you want in the model and open up the Ifc debug panel. Inspect from object, and there you go. You can now browse through all of the relationships in here.
Okay, here I'm going to analyze the contents of our Ifc file using only the command line, the Python interface of FreeCAD. I'm importing the Ifc OpenShell module, which is responsible for dealing with Ifc files in FreeCAD as well as in BlenderBIM. So we start by opening our file. This won't open the file in FreeCAD, just import it with Ifc OpenShell, and now we can analyze it. For example, we can grab all the wall objects in these files, but we have seen that they're not saved correctly. So now we're taking all the Ifc building element proxies from this file, and let's try to, from these, to grab the walls. We've seen that this was saved. All the walls have the mur name, which means wall in French. So we are actually able to isolate these by name in this case. So here we have all our walls, provided of course that they were correctly named, but let's assume it is. Ifc OpenShell has a mode to work with BREP geometry instead of mesh. BREP is the same geometry that we use in FreeCAD. So by setting this BREP setting, that's what I'm doing now, we are able to work with BREP geometry. So the geometry that IFC OpenShell will deal with now is compatible with FreeCAD. So I'm opening a new window, a new FreeCAD document now, and I'm getting the shape from my wall here, and I transform this geometry. I extract the BREP data here. Oopsie. Yeah, this way, and this BREP data can be directly placed in a FreeCAD shape. So we first create a shape, and we insert the BREP data from IFC OpenShell in it. That's basically what the IFC importer does behind the screen for you. And now we have this FreeCAD shape, and we put it on screen, and we see we have our perfect shape here, the way it was in the IFC file. We can now do a lot of interesting things, such as checking the volume, or using an interesting features of all FreeCAD objects, which is their bounding box, which is a cubic.
Most of the time, you're not interested in 90% of the things in your building. Counting walls and pipes is not going to impress your boss. Instead, you're interested in maintainable assets, things that cost money to replace or repair. With these modules, let's grab all the maintainable equipment. This will skip all the boring stuff like every pipe fitting and every clamp and just get us the important equipment. Here's a list of all the manufacturer models of things which are installed in our building. Let's get a single instance. In this case, we picked out a single manufacturer model of a 205 by 205 supply air diffuser. Now let's find every occurrence of this model that is installed in our building. Now for every installed diffuser, we can check which mechanical system or subsystem it's part of. So we can see that this is part of the mechanical supply air 1 system. Let's grab the rest of all the other elements that are part of this system. So very cool. We can now also visualize this in the graphical environment by clicking all our objects and pressing Draw System arrows. And there we go. So now we can see that our air conditioning should be working. Have you ever walked over to the accounting department and wished that instead of looking at code all day, you could play with spreadsheets instead? Well, now you can do that too. So let's say we want to find out how much you're paying in rent per square meter and whether what you signed on the lease contract actually matches what's in the building design. Let's get a schedule of all the spaces in a building. The attributes I've written here are basically the same attribute names that you'll see in the interface over here. So let's export our model and specifically only the space elements for each room in the model. And here we are. Our building has a total gross floor area of 965 square meters. What's super cool is that whatever you choose to export, you can now edit in the spreadsheet and re-import those changes back into the BIM model. So let's turn this innocent residential building into a data center. Awesome, and now let's re-import this back in. And let's check out the results to make sure that we've changed our data. Great job. Sometimes your real estate developer will market something called a digital twin of your building. That sounds really advanced, but it's basically a BIM model that has live sensor data connected. The high-level description of your building systems are usually both described in IFC in your BIM model and sometimes in something called brick schema. To view a brick schema model, just load the project down here. And inside equipment, you can see all of our smart devices. So for example, this air handling unit has various data points associated with it, including a mixed air temperature, supply air pressure, supply air temperature, and so on. It also feeds some VAV boxes and is fed by a chiller. Each one of these data points might have time series data associated with it. It's basically a key to a location in a database which records the sensor data in real time. We can also access our currently loaded brick model in the Python console. This graph object is an RDF graph, and brick schema uses the RDF lib module under the hood. So we can write Sparkle queries to query it. Sparkle is a bit like SQL, so it's pretty easy to pick up. So here's an example Hello World query, where we get all of the brick equipment types. Now, we don't yet have a library of utility functions, but it's good to share that this type of thing exists in the open source world.
Okay, we're now going to perform some cleaning operations on our model. I am now opening the Ifc model the normal way in FreeCAD, that is using file import, which doesn't deal with the Python console, but directly imports the objects in the FreeCAD document. You see, we have a couple of objects that are not inside the level structure. These are mostly leftovers, I think, from other operations in ArchiCAD. I'm removing a couple of, here are a couple of, we remove the containers because we won't need them, the site and the project, so I can grab directly my object, that's easier. We have a couple of decorative objects here. Fortunately, they are correctly gathered in a layer, so we can just delete all the objects from this layer, which are all furniture and these kind of things, and now we have our clean model without anything. I can remove these unused layers too. And now we can fix our main problem, which was that the walls were not walls, and that's one of the most easiest things to do in FreeCAD. We can just filter by name. Here are all our walls, and we just change their IFC type, and that's it. The file is basically fixed. These kind of fixes are really easy and quick to do in FreeCAD, and we export back to IFC, another file, and we will be able to check that our fix was correctly done by opening it again in IFC++. Here it is, and let's check. Yes, our walls are now. Another very quick, interesting thing to do with the model that you import in FreeCAD is just to extract a quick plan view, for example. So we use this Shape2D tool to just extract a plan view from a level. We make a copy of it, and we change its setting to just show the cut lines, and by changing the thickness of this cut line, we now have a perfect plan with cut geometry and viewed geometry, project geometry. So we have a nice plan view. We can add some more stuff on it, like a couple of dimensions. For the cleanliness, we place all these things in a group, and this group contains our 2D data, and we can, for example, export this as a DXF file. Which we can open in QCAD to check if everything.
Now, BIM isn't just about architectural design and engineering services. It also includes construction. You'll find information about material sustainability, cost schedules, and information about all the resources used during construction. Now let's pretend that we're going to create a construction schedule. Then let's get the BIM model that we've already loaded into our session. The first thing we're going to do is add a new work schedule. Let's call it construction. Our schedule will have a whole bunch of tasks in it. This add task function will create a task, give it a name, and label it as a construction task. It also needs to add a task time so that we can record the duration of the task. Let's arbitrarily set every single task to start on the 1st of January and have a duration of 1 week long. Very cool. So let's create our very first task, start building the building. Then, for every single story in our building, we'll add a brand new construction task to construct that story. We'll also want to assign every single physical object in our BIM model to the construction task. So let's loop through every product that exists in each building story, and then assign it to our task. Finally, we need to make sure that each task will happen one after another, so that when one task finishes, another task starts. This is called creating a sequence, and it relies on having a predecessor task and a successor task. So let's make our start task our very first predecessor and make the predecessor change every time we go up a story. So because we've been very lazy with dates and everything starts in the first, we can ask IFC OpenShell to calculate the dates automatically for us using the cascade schedule function. And that's pretty much it. We now have our schedule. So let's run this code. So here's our construction schedule and all of the tasks that we've just created. If we press this button, we'll see a Gantt chart of the tasks that we've just described. The BlenderBIM add-on can also automatically generate an animation of the construction schedule that we've just generated. Let's take this one step further. So let's imagine we live in a house next to this building. Let's find out when during the construction process that this building will start to block our access to the sun. And this is a serious issue because sunshine gives us vitamin D, it makes us happy, and we know when to wake up. So let's set our coordinates of where we are in the world, tell them where north is, and let's get the worst case scenario by choosing the winter solstice. Now we can jump anywhere throughout the construction process as well as change the time of day to figure out when our sunlight will be blocked. I hope you've enjoyed watching a few fun building data hacks. Now, buildings are a public good and impact the entire world. So hopefully in the future, the public will have more transparent access to our building data, the same way that we already have lots of access to public GIS data. Right now, our building data is pretty low quality. The data is pretty messy, and a lot of data is missing because our industry is still learning how to use BIM effectively. If you ever get the chance to play with it, and especially if you're on the receiving end, please reach out and we'll help you get started to hack on your built environment. Thanks for watching.
FreeCAD and also the BlenderBIM. Yorik, can you say a few words about what the future looks like for the integration between this work and the work that's being done on BlenderBIM?
Yes, sure. Hi, everyone. Well, there is much to do, actually, since BlenderBIM now use a model where the IFC file is controlling everything. Everything you do in Blender saves automatic to the IFC file. That means that when working in BlenderBIM, you always produce a valid IFC file. And that's something we would like to do in FreeCAD as well. So basically that means reusing a part of BlenderBIM as a kind of engine in FreeCAD. That's basically my plan for the next months, years, or something like that. And so we would be in FreeCAD as well able to produce like always valid and same IFC file.
Excellent. And real quickly in the last 20 seconds that we have, if people want to help contribute, where should they go?
Actually, there is a forum for joint FreeCAD and BlenderBIM that is OSArch.org. And that's where most of these debates and questions happen.